Hmm?
Oh,
So one of the best ways of learning is through what they call spaced repetition. You repeat over and over, you get stronger and stronger. The knowledge gets deeper and deeper in you. Okay. So our objective today is to demystify this idea of descriptive statistics. Okay, which is basically the foundation of data. Statistics, of course, is a major foundation of data analytics. And in statistics, we have descriptive statistics and we have inferential statistics. But the place to start from is usually descriptive statistics. Okay. So we are taking an overview of descriptive statistics. Introduction. Descriptive statistics is a branch of statistics that focuses on summarizing and presenting data in a meaningful way. Unlike inferential statistics, which makes prediction based on data, descriptive statistics provide simple summaries, allowing for an easy understanding of data trend distributions and patterns. So descriptive statistics is basically for summarizing data or for presenting data in a very meaningful, insightful manner. Okay, in a way in which that data would provide useful insight. Okay, so that's usually what descriptive statistics focuses on, right? So it's for summarizing data and for presenting data. Unlike inferential, which is for making predictions. Okay? Now, inferential statistics, of course, is based on descriptive statistics. Now, the key components of descriptive statistics. Descriptive statistics is broadly categorized into three main areas. Descriptive statistics is broadly categorized into three main areas. One is measure of central tendency. Measure of central tendency describes the central or typical value of a data set. The three main measures are mean, median, and mode. Okay, mostly arithmetic mean. These are the three main measures: arithmetic mean, median, and mode. Okay, of course um, there are lots more, but there are lots more. But when we are doing analytics, we are not doing the whole of it. I mean, it's not like just taking a purely statistics or a purely statistical class. Okay, we focus on the most important aspects as far as analytics is concerned. All right. For example, this measure of central tendency I just showed you now. Here we are saying the main measures are mean, median, and mode. If we take a look, for example, let's take a look at Wikipedia. Let's see what Wikipedia would say about measures of central tendency. Okay, there's a whole lot there. In statistics, the central tendency or measure of central tendency is a central or typical value for the probability distribution and so on and so forth. Okay, now look at the measures of central tendency given here. Look at them. Arithmetic mean, which is sometimes simply called mean, median, mode. Can you see is these are the first three dimensions, okay? Because they are the most important. But beyond that, you see, we have generalized mean, we have geometric mean, harmonic mean, weighted arithmetic mean, truncated mean, interquartile mean, mid-range, mid-hinge, quasi-arithmetic mean, tri-mean, mean-sorized mean, geometric median, quadratic mean, simplicial depth, Turkey median. Can you see that? Can you see that there's a whole lot? Okay, but if we now begin to do all this, we are just wasting time. Okay, we are supposed to, our focus is on the main thing, because what we're actually doing is what we're actually doing is data analytics, not just purely statistics. There's a difference, okay? So we don't veer off and begin to do all that. No, it's not necessary. All right, so now these are the most important. Of course, as we go on, we'll touch a few more, but these are the most important measures of central tendency. Okay? Yeah, as far as data analytics is concerned. Now, measures of dispersion, also called measures of variability. These measures indicate how much the data varies from central value. They help in understanding the spread of data. Okay? They help in understanding the spread of data. Okay? So what are these measures? The most important here are the range, which is the difference between the maximum and the minimum values. That's maximum minus minimum, right? That's the range. Oh, we've not talked about these measures. Yeah, measures of central tendency. We said we have the mean, median, and mode. Of course, the mean is what? Also called average. Okay, we all know what average is. Okay, arithmetic mean is average. When you just say mean, you don't say the type of mean it is. Just know that it's arithmetic mean we are talking about. Okay, just know it's arithmetic mean. It's not geometric mean. It's not harmonic mean. It's arithmetic mean. That's the popular type of mean. This is simply average, which is sum of all the values divided by total number of values. Okay. Okay, it is sensitive to extreme values, which are called outliers. Okay, it is sensitive to extreme values. You know, these kind of things, these are the kind of things that an analyst should take note of. Okay. These are the kind of things that an analyst takes note of. The mean is sensitive to extreme values. I'm going to explain that further. This statement is what kind of differentiates, one of the things that differentiates it from median. Okay, median is less sensitive to extreme values than mean. Right now, the median is the median value when data is sorted in ascending or descending order. It is less affected by outliers. Outliers are extreme values. Okay, maybe extremely large or extremely small value. Do you understand? Those are outliers. The modes, this is the most frequently occurring value in a data set. A data set may have one mode, in which case we call the data set a unimodal data set, or it may have more than one mode, which is multimodal data set. Some data sets don't even have mode at all. Okay. When I say that some data sets don't have modes, do you think that is correct? Do we agree with that? Why would the data set not have mode? So I want to hear from you now. Why would it be that a data set does not have mode? How is that possible?
For a data set to have mode, the mode must be characterized by repetitions of numbers.
Okay.
So when a data set does not have repetition of numbers, then a mode may not be present in that data set.
Okay. Yeah. So when there's no when some data sets, rather when some values are not more in number, in occurrence than other values, some other values, of course there will be no mode. Okay. There will be no mode. For example, a data set where, thank you, Mr. Doty, that was a good explanation. A data set where a particular value appears only once. There's no mode in that data set. Okay. So a data set may not have mode, may or may not have mode. Okay. Now, these three, the important thing to note, you see, like I tried to explain just now, we are not doing statistics, we are doing data analytics. So as data analysts, there are certain elements, certain aspects that we take note of specifically, right? Now, I want you to know that these three, they are all measures of central tendency, right? Which means they give information about the convergence of the data. Okay, they give us information, insights as to how the data tend to converge toward the center. That's why I say central tendency, how the data is centralized. Okay, that's what they try to tell us, right? So, for example, take mean, for example. When you take the mean of the data set, what that's simply telling you, maybe median, it might be easier for us to relate what I'm trying to explain with median. Take median, for example. Okay, the median, when you compute the median of a data set, whatever you get, let's say for instance you get a median of 50. What that simply means is that the number at the middle of that data set is 50. Is that not so? Okay, so it's telling us about the center of the data set. That's what it's saying, right? That's what it's saying. Now, I use median as an example because for median, it's very obvious because to get median, you have to arrange the numbers. By the way, we are going to solve all these, take examples as we get on. Now, why? Because to get median, you have to arrange the numbers, all the numbers, in ascending order. If there are odd number of items, then the middle number, one middle number, the middle number will be the median. If there are even number of items, then the two middle numbers, the two numbers in the middle, will have to be averaged. You have to find the mean of those two numbers to get the median. So it's very obvious, it's very clear that the median is actually centrally located in the data set. Is that not so? It's at the center of the data set. Okay. Now, it's very easy to see that with the median, but what I'm trying to tell you is that the three of them are meant for measuring centrality, just like median measures centrality. These other two also attempt to measure centrality, to give an indication, some sort of indication of where the center of the data set is. Okay? Yeah. So you may not easily see how these two do that, particularly mode. But as we go on, by the time we talk about distributions, particularly normal distribution, then you understand why these ones, especially mode, is also considered a measure of central tendency. And of course, mean, it's also easy to see that mean is a measure of central tendency because you are finding the average, you are adding all the numbers together, divided by the number of items. So you see that the number you get as the mean, try to, is somehow either at the center or close to the center. Okay, so this is why these are called the measures of central tendency. Now, as an analyst, something that as we get on in this course, you will understand that as an analyst, you should know when each of these measures are more appropriate. There are situations where median is more appropriate to be used than mean. There are some situations that requires you to use mean instead of median. So those are the things, among the things we are going to learn. Okay, so how to know which is the best measure of central tendency in a particular circumstance. Okay, so understanding such things, those are the things that make you an analyst. Okay, all right, so, but for now, we can't delve into that now, that will be later. So these are the measures of central tendency, the popular measures of central tendency. Now let's move on to measures of dispersion. Now take note, the key word I've used here, we have used there is what? Central or center. Center. In fact, another way of describing this measure is to call it measure of centrality. So it measures how the data converges. It's trying to give an indication of the measure of the central position of the data, the center of the data. So now let's move on to measures of dispersion, also called measures of variability. Okay. Now, as an analyst, you want to know how the data converges at the center. You also want to know how the data spreads from the center. How it spreads from the center. That's where measures of dispersion comes in. Okay, these measures indicate how much the data varies from the central value. They help understand the spread of data. Okay, you know, when a lot of students just when they do things like statistics, these measures, they just compute them and that's it. Okay, and but when you are doing data analytics, it's not just to compute them. You should know how to you should know the implication of anything you are doing. Okay. Now, the measures of dispersion is a measure of the spread of data. In other words, how data sort of diverges from the center. Okay. Yeah. So the range, for example, look at range. The range is the difference between the maximum and minimum. If, for example, I say the range of a particular data set is 1,000 and the range of another data set is 50. So what it means is that the one that has range of 1,000, you can see that that one, the data set sort of spreads over a wider range of values than the one that is 50. Are you following me? The one that has range of 100 is more dispersed. The one that is 50 is more converged, is narrower. Are we together?
Yes, we are together. I'm with you.
Okay. Hope
Yes.
we are all following.
Yes.
Yeah. If you get disconnected, just come back with the same link. Okay, anytime that happens. Now, variance is another measure of dispersion, which is the average square difference of each value from the mean. Okay. So when you are calculating variance manually, as we go on, we'll see the how that is done. You see that when you are calculating it manually, what you try to do is get the difference between the various values of the variable, let's say x, from the mean, and then you square that, okay, and then the sum of all those squares, okay, divided by the total frequency. So variance is used to get the average square difference of each value from the mean. Now, the important thing I want you to, what we are doing now is an overview. We are not looking at the specific computation now. We are just trying to we are looking at overview of descriptive statistics. We are trying to see the purpose of each of these measures. Okay, it's very important to understand the purpose of what you are doing. It's not just to calculate. Calculation is very direct and straightforward because, especially when you are using the computer, a software like Excel, for